Now, so far we've worked with linear equations, but you can also have systems of nonlinear equations. You might have a quadratic with two variables equals a linear, and a linear, or you might have two quadratics, or you might have a quadratic and an absolute value, or even a radical. So we need to find values of x and y that satisfy both equations. We'd still give our answers as ordered pairs. Now, solving nonlinear systems with real equations, there's at least one equation that is not linear. It's called a nonlinear system. Substitution method works well in many systems, particularly if one is linear, as in the next example. What I can do here is just solve. I'm going to take the top equation and solve it for y. Say y equals negative x squared plus 6. And in place of the y in this equation, I'm going to put negative x squared plus 6. So x minus negative x squared plus 6 equals negative 4. So x plus x squared minus 6 is negative 4, or x squared plus x minus 2 equals 0. And that factors into x plus 2 and x minus 1 equals 0. So x equals negative 2 and x equals 1. Now we expected two answers for x because we have an x squared. It does give us two separate answers for y. So we'll have negative x, or negative 2 minus y equals negative 4, or negative y equals negative 2 and y equals 2. So one ordered pair for an answer is 2, negative 2. And then we could also, using the 1 minus y equals negative 4. So y equals negative 5, negative y equals negative 5, and y equals 5. My other ordered pair is 1, 5. So notice I have two sets of answers. Two x values gave me two different y values, and I need to match them up as ordered pairs with my answers. Solving a nonlinear system is necessary to check by substituting proposed solutions into each. And then remember to take both positive and negative roots when solving ones raised to various powers. And nonlinear systems where both variables are squared are best solved by addition. So here's one where we have both ones squared. And let's take the top equation and multiply it by negative 4. So I'll have negative 4x squared minus 4y squared equals negative 36. 5x squared equals 0. So x squared equals 0 and x equals 0. Two different ways x equals 0. I'm going back to the top equation. 0 plus y squared equals 9. Y squared equals 9, and y will equal plus or minus 3. We have to do both. So if x is 0, y is either 3, or x is 0 and y could be negative 3. So we really do have two sets of answers. We know it works in the top equation. This would be 0 equals 4 times 9, plus 4 times 9 equals 36. So those do, both pairs actually do check. Now here we have an absolute value. And what I'm going to do, since I have a y equals, I'm just going to substitute that in. So 2 times the absolute value of x minus 1 minus x equals 1. So 2 absolute values minus 2 minus x equals 1. I want to isolate the absolute value. So I want to keep this on one side. 2 absolute value of x's equals x plus 3, and then I only want one of those. So the absolute value of x equals x plus 3 over 2. Then since it is, now I've isolated the absolute value. So from there, I know that x either equals x plus 3 over 2 or x equals negative of x plus 3 over 2. Cross multiply, now I have 2x equals x plus 3. So x ends up equaling 3 is one proposed solution. And here with a negative, I'm going to make it negative 2x equals x plus 3. So negative 3x equals 3, and x equals negative 1. This is another proposed solution, and now I need to find y. And I'm going to go to the bottom equation for that. So 2y minus 3 equals 1, 2y equals 4, and y equals 2. One proposed solution is 3 and 2. And then using the negative x, or negative 1, 2y plus 1 equals 1. So 2y will equal 0, and y equals 0. So negative 1, 0 is the proposed solution. Now I know those work in the bottom equation because I used the bottom equation, but let's check the top. Does 2 equal 3 minus 1? Yes. Does 0 equal absolute value of negative 1 minus 1? Yeah, that checks. So both of these work. And these are my two proposed solutions.